Hello everyone, welcome to BHARGAV SUBS. So in today's class, let us discuss an example regarding method of images. Right, like in previous videos we discussed the conditions for method of images and procedure to apply in the method of images and what is method of images and the basic definitions, and we all discussed some topics regarding method of images. Now in today's class, let us discuss by taking an example. Okay, application of method of images. So for that, what I am taking a grounded shell in which the potential was 0, right? So potential was 0 for that grounding shell. So grounded means like potential getting 0 on the surface. So I am taking the example and I want to find the potential at a point P. Either it may be on the surface or at some distance. So let us find the potential for that given example. Okay, so the question was find the potential and potential at P at a point P and potential at certain point P and induced charge. Okay, so I told you like there is a charge induced due to charge present outside. There is a charge induced inside the shell due to the potential was 0. Now if the potential was 0, if there is a single charge present, then there is a induction of another single charge which was of opposite sign. Okay, so induced charge of a grounded conducting cell. Okay, so like this is the example, grounded conducting shell. So I am taking now a grounded conducting cell. So I took a grounded conducting shell. So this was the center. Okay, so I am taking a point charge which was outside the shell. So for suppose here I took, right, so I am joining these 2 points. Okay, due to the charge present outside, there is a charge is induced inside the shell. So this was grounded. This conducting shell was grounded. Conducting shell means it contains like free electrons, okay, inside. Yeah, now due to this there is a charge induced. So at a point P, so I am considering first of all I am taking the point P on the shell here. Okay, this is the point P. So now I am joining this point. Okay, now I am joining this point P. Okay, so it is the point, and here theta is the angle between OP and for suppose I took this point as OA. Okay, and again due to the charge present outside, a charge was induced inside the shell which was minus Q dash. Q dash why I indicated? Because it was unknown charge. The charge induced, we have to find that unknown charge Q dash. So it was a negative sign. So let us consider this as point B. I am joining these 2 points, right? I am joining the point at B, and point P. Okay, this point as B. Again I want to join here AP. So this was A, this was Q charge. So now I want to find the potential. Before finding potential, right, potential at point P depends on the 2 charges which was at outside and which was at inside, correct? I already told you it doesn't depend only the charge present outside, it also depends the charge present inside the conducting shell. So with this we can write here it is grounded means the potential is equal to 0. So potential at point P, potential at point P. What is the potential at point P? Vp is equal to, so potential at point Q plus potential at Q dash. Okay, due to the charge present inside the shell, correct? So what is the potential at point P? It is on the surface, no? So P is on the surface. So on the surface the total potential was 0. So 0. Potential at Q, potential at a particular point which is present at a certain distance, the formula was 1 by 4 pi epsilon naught charge by the distance. if I consider the distance between O and A, if I consider this distance as A, small a, if I consider between O and minus q dash, if I consider this as small b, correct? So A and B, and potential at q, what is the potential at q? 1 by 4 pi epsilon naught charge q by what is the distance A plus 1 by 4 pi epsilon naught charge q dash by B, correct? Now I am calculating again I want to transfer, like this was charge present, so 1 by 4 pi epsilon naught A by q by A is equal to, if I transfer this to left hand side, so what I will get, minus 1 by 4 pi epsilon naught q dash by B. Okay, so 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught get cancelled, so q by A is equal to minus q dash by B. Okay, and again if I cross multiply on both sides, so q into B is equal to minus q dash into A. Okay, so let us consider this as statement 1. I consider this as statement 1. Now I want to find the distance of AP and BP, correct? I want to find the distance AP and BP. So for finding the distance, that those sides, I will apply, like, see, I will consider the triangle OAP. Okay, consider triangle OAP. So OAP, what is triangle OAP contains? Like, you can apply the vector law of addition. OP bar is equal to OA bar plus AP bar. OA bar plus AP bar. So I want to find AP bar now. So AP bar is equal to OP bar minus OA bar. Let us square it on both sides. So AP square is equal to OP square plus OA square minus 2 OP OA cos theta, because I have to apply the angle between it was a vectors, no? So I have to apply the angles between OP and OA. OP and OA, what is the angle? Theta. So like, I think, see, you know, this was a cosine rule, you know, if you know two sides, now you want to find the other side, then you can apply the cosine rule. If you know the two angles in a triangle, if you want to find the third angle which was unknown, so you can apply the cosine rule. So for finding unknown sides or unknown angles, you can apply cosine rule in case of triangles. Okay, you will get this topic in the triangles topic, like similar, congruent are there, no? So in that topic you will get these cosine rules and sine rules all. So what is then AP? I am sending the square to the right hand side, so square will get root. Okay, OP square plus OA square minus 2 OP OA cos theta whole power 1 by 2. Now let us consider this as equation 2. This was equation 1, that was equation 2. AP is equal to how much? AP. Okay, AP. Yeah, let us write this one. Now I want to find the BP also. So what is BP? For BP, I have to consider triangle OBP. So consider triangle OBP. Now what I will do? OP bar is equal to OB bar plus BP bar. Same vector law of addition I am applying in this triangle. OP bar plus BP bar. Now I want to find BP bar. So BP bar is equal to OP bar minus OB bar. Again I am squaring on both sides. So what I will get? BP square is equal to OP square plus OB square minus 2 OP OB cos theta. Again the angle between OP and OB. OP and OB was theta, so cos theta. So what is BP then? BP is equal to OP square plus OB square minus 2 OP OB cos theta whole to the power 1 by 2. This is the state equation 3. So this was 2, this was 3. Okay. So I found AP and BP. Now what I have to do here, the BP was here, I think a small mistake was there. Here the potential at point P, no. So the potential at point P we have to consider. So distance of P from Q and distance of P from Q dash. So what is the distance of P from Q? AP. Okay. So this was AP. And what is the distance of P from B? BP. Correct? It was BP. So 1 by 4 pi epsilon naught Q by AP is equal to minus 1 by 4 pi epsilon naught Q dash by BP. Okay, AP BP, and Q by AP is equal to minus Q dash by BP, and Q into BP, Q into BP, BP is equal to minus Q dash into AP. Up to here clear? This was the first statement. Because see, potential at point P is due to the potential due to the plus Q charge and potential due to the minus Q dash charge. So potential due to plus Q charge is the due to the Q, no. So what is the distance? AP. Potential at P due to minus Q dash, now what is the distance? BP. Yeah. So like we have to consider these two distances. So I applied. Now I got AP, I got BP. Okay. Now I have to substitute 2 and 3 in first equation. So let us see what I will get. Okay, just I am substituting the values of AP and BP here in the first equation, right? Yeah. So let us do that. So I am taking the first equation. What is the first equation? What was the first equation? Q into BP. So from 1. So what is the 1? Q into BP is equal to minus Q dash into AP. So I am substituting 2 and 3 in first equation. 2 and 3 in first equation. Okay, 2 and 3 in first equation I am considering. So Q into BP, no. So what is BP? Q into BP. OP square plus OB square minus 2 OP OB cos theta whole to the power 1 by 2. Similarly, minus Q dash into AP. OP square plus OA square minus 2 OP OA cos theta whole to the power 1 by 2. Correct. Now I am squaring on both sides. Squaring on both sides. So what I will get, you know, squaring on both sides means Q square into, this is whole to the power 1 by 2, no. So 2 by 2, this which is 1. So OP square plus OB square minus 2 OP OB cos theta, okay, is equal to, minus will get positive. If you square, you will get positive value, minus. So Q dash square. So I will get OP square plus OA square minus 2 OP OA cos theta whole to the power, yeah. Now see these, wait, let us split it. Q square into OP square plus OB square minus 2 Q square OP OB cos theta is equal to Q dash square into OP square plus OA square minus 2 Q dash square OP square, sorry, OP OA cos theta. Okay, so these two equations, like this is the left hand side and right hand side are equal when, see, this was true for all angles of theta. Okay, this was both are equal all angles of theta when the cos theta should disappear. Because if you change the values, if you change the values of theta, you will get different values on both sides. But if you vanish this statement, okay, this term and this term, okay, if you vanish those terms, then like these should be equal, must and should be equal, because it was present q dash. Okay, these both should be equal first of all, then only you will get a correct equation here. Okay, this is correct, this is true, this is true for all angles of theta, for all angles of theta. So when cos theta is disappears, okay, it should be disappear, then only it will be equal. So what I am doing here, for disappearing this, okay, I am equating the terms here, or this term and this term I have to equate. Okay, then I can able to find the value of q dash, what I will get. So q dash, then I have to substitute here, then I can able to find the q dash charge, this like induced charge. Okay, so minus 2 q square OP OB cos theta is equal to minus 2 q dash square OP OA cos theta. Okay, here cos theta get cancelled, OP get cancelled, 2 get cancelled, minus get cancelled. Finally, what left? Q square into OB is equal to q dash square into OA. So what is the OB? We took distance small b, so q square into b is equal to q dash square into OA, distance from O to point A. What we took? Small a. Okay, so I want q dash square now, so q dash square is equal to q square into b by a. So then what is q dash? I am transferring square to that side, so it will get root q into root over b by a. So finally I got this was q dash is the root over b by a. Now I have to find b value, then only it was like we will get a satisfied value, like correct value. So you have, because it was a and it was b. Okay, because if you find the b value, then you can find like the induced charge exactly at what distance it was induced from the center O. Okay, the charge was induced, but we don't know the distance initially, so we have to find distance. Then you have to, because the charge initially what you are keeping, that distance you know, small a, because you are placing the charge at a certain distance, then due to that charge there was a charge induced. That distance it is unknown, that distance also, because it was induced at certain point inside the shell. We have to find the distance and you have to find the induced charge. Again I am substituting this q dash in the above equation. Okay, this, if you substitute this q dash in this above equation, what will happen? You know, I told if I substitute here in q dash in this place, then the term here and here will disappear, cos theta term will disappear. These both will get equal because we took both are equal. When then you get q dash. If you substitute the q dash here, then this term and this term is going to cancel, because both the terms will get and equal. So if you transfer this side, you will get like minus here, this is minus. If you transfer this side, you will get plus. So the both terms will get cancelled, like it will get 0, it will neutralize. Okay, so it will get balanced. So I am going to substitute in the above equation, then I am automatically these terms is getting 0 now, this term and this term, so no need to take those terms. I am taking only this term and this term. So I am substituting in the above equation, right? So q, after substituting, q square OP square plus OB square is equal to q dash square, no, q dash square. After substituting, you will not, there is no need to write these terms. So q dash square, no, q root over b by a whole square into OP square plus OA square. Okay, so you know OP is the distance of point P from point O. We took point P on the shell, so the distance was radius of the shell. So q square into r square plus OB square. What is OB? Small b. Small b square is equal to q square into b by a of OP. OP same here, r square plus OA small a square. Okay, so I am multiplying all the terms here. So q square into r square plus q square into b square is equal to, so q square into b r square by a plus q square into b a square by a. Okay, so this a and 1a get cancelled, and now I am taking all the terms to one side. All the terms to one side I am taking. So then what I will get? Q square r square plus q square b square, q square r square plus q square b square is minus q square b r square by a minus q square ba minus q square ba is equal to 0. Again I am taking common r, like q square r square in these two terms. So q square r square I take common. So what I will get? 1 minus b by a, 1 minus b by a, and q square in these two terms, q square b also common, I think. Okay, b, what I will get here? One more b was there, minus a is equal to 0. So q square r square a minus b by a plus q square b into b minus a is equal to 0. I am transferring this term to right hand side. So what I will get? Q square r square into a minus b by a is equal to q square b. If you transfer to right hand side, you will get minus, no? So b minus a. So multiply minus with inside. So q square r square into a minus b by a is equal to q square b a minus b. So this q square get cancelled, a minus b gets cancelled. So r square by a is equal to b. So I got b, r square by a. So now I am substituting this b value in this equation, q dash. So now what I will get? Q dash is equal to q root over b by a. So q into root over, what is b? R square by a, into 1 by a, correct? No. So again what I will get? Root over r square by a square, which is r by a. Okay, root over r square by a square is r by a. So q dash, what I get? Q dash is equal to r by a. So I know the radius of the sphere, conducting sphere, and also I know the distance of point A from origin. Initially I am keeping the distance, so I know the distance and I know the value of a, right? Wait, here q was there, no? Q, so q dash is equal to q into root over r square by a square. So q of q r by a, so the, you know the what charge you are keeping outside, and you know the radius of the conducting sphere, and you know the you know the distance, like initially what charge you kept, you know the distance small a. So if you substitute those values, you will get the induced charge. Okay, and I find the induced charge. Now what I have to find? Potential at point P. Potential at point P. I know the potential at point P is due to the charge Q and charge Q dash. So I know the now Q dash value. I know the Q value, correct, Q. So I will apply 1 by 4 pi epsilon naught charge by distance. Both the distance I know, because I know the B value. I found the B value. I know the A value initially. I know the charge Q dash. I know the Q value, Q charge. So finally I got the potential by applying total potential is equal to potential at Q plus potential at Q dash. So let us apply that to find the total potential value. Okay. So for finding total potential value, I have to sum the total potentials due to charge Q and charge Q dash. So what I will get finally? So potential at point P. So I will get Vp is equal to potential at charge Q plus potential at charge Q dash. So potential at Vp is equal to, yeah, you may ask, like, potential at point P is 0, no? Potential at point P is 0, no? So like, why we are calculating here? There is 0 on the surface, 0. Now what I am doing, I have to find the potential at certain distance. Okay, that, like, P is not on the surface. For example, P is not on the, if it is P was lying on the surface, then you calculate like the potential on the surface was 0. If the potential was not on the surface of the sphere, I am taking the point at certain distance from the origin O, then what I will get? Potential at Q 1 by 4 pi epsilon naught, okay, charge Q by distance of Q from origin. What is the distance? Small a, plus 1 by 4 pi epsilon naught Q dash by potential at like distance from of Q dash from O, which was B, right? Again, if I take the distance of, like, I am taking a unknown distance now, like I am keeping the point charge, like point at certain distance now. So I am taking OP now is equal to small r. Okay, previously it was capital R. Before it was OP is equal to capital R. Okay, previously. Now I am taking after now, so like I am considering the distance is smaller. This is unknown distance. Okay, so in this value, in this R value, you can place like capital R also. Then you will get potential 0, correct? Because the bounded, you have to know the bounded condition. The potential is 0 at two cases. One is at radius R and one is at a certain distance small r. Sorry, at a certain distance, at a infinite distance. Potential is 0 at surface on the radius and potential is 0 at infinite distance. So in the two cases the potential was 0. So I am considering the OP distance was smaller. Then what I will get? See, you know that if it is the triangle, if you take, this was small a, no? This was small b, no? Okay, this was small a, no? This was small b, no? This was point A, this was O, this was B, and this was P, and this distance was small r. Okay, OP now I took small r. And again, if you want to find, applying cosine rule, same. If you want to find here small a, if you want to find small a, then what you have to find? What you know, like by applying cosine rule, root over except this side you have to add remaining two sides, like OP r square plus AP square minus 2 r. Sorry, like again we did a small mistake. We have to find the potential at point P now. So we have to calculate, we have to write here the distance of point A from P, which was AP, and point B like point q dash, charge q dash, where the charge q dash present this here charge q. So point free from q dash, so which was BP. Okay, so this was A and this was B. Now applying cosine rule, if you want to find AP, what is AP? Root over r square plus OA square. OA square means A square minus 2 AR cos theta. Here the angle was theta. Same here, BP is equal to root over r square plus B square minus 2 BR cos theta. Right. Now I am substituting the values. Potential at P is equal to 1 by 4 pi epsilon naught Q, you know, Q. AP, what is AP? Root over r square plus A square minus 2 AR cos theta plus 1 by 4 pi epsilon naught. Again Q dash, you know the Q dash value, QR by small a, QR by small a, right. Again I am know the B value, r square plus B square minus 2 BR cos theta. Okay, I know the AP and BP and Q dash also. Now I am taking Q by 4 pi epsilon naught common, Q by 4 pi epsilon naught common. What I will get? 1 by root over r square plus A square minus 2 AR cos theta. Correct. See here, I have to let us substitute. So 1 by plus r by A by root over r square plus B square minus 2 RB cos theta. So if I transfer this r by A to denominator, I will get A by R. So Q by 4 pi epsilon naught. So 1 by root over, I think you have to substitute here Q dash, minus Q dash, no, the induced charge was minus Q dash, right, with negative sign. So minus Q dash, so minus you will get here. If I transfer like 1 by 4 pi epsilon naught r square plus A square minus 2 AR cos theta. The B was like initial unknown, no, so you have to convert in the form of A. So r square by A minus 1 by, if I transfer r by A to denominator, you will get A by R root over r square plus, what is B square? R square by A whole square, r square by A whole square. Okay, minus 2 R, again B was r square by A, r square by A into cos theta. Okay, now Q by 4 pi epsilon naught 1 by root over r square plus A square minus 2 AR cos theta minus 1 by root over, I will multiply the A, if I transfer the A to inside, so A by R to inside, what I will get? A square by R square into R square plus R square by A whole square into A square by R square minus 2 R A by R whole square into R square by A cos theta. So I got this value. Okay, again what I am doing, I have like, again like see, Q by, it is at VP. Okay, the potential at VP. So Q by 4 pi epsilon naught 1 by root over r square plus A square minus 2 AR cos theta minus 1 by root over, so A r square, A square r square by capital R square, no, so A R by R whole square plus R square, see 1 R square whole square gets cancelled, 1 here A square, no, so A square gets cancelled, so final I got R square. So R square whole square, no, so here 1 R square there, it got cancelled, and again here A square and here a square because it whole square, no, so we will get here a square, so a square gets cancelled. So finally I got r square minus 2r, and here 1a get cancelled, and r square gets cancelled, 2ra cos theta. Yeah, it's okay now. Yeah, this is the VP potential. I have to confirm is this correct or not. How I can confirm? Okay, I already told you at small r place you can also substitute if you want to find the potential, so the potential at point P means what? The distance from the center over to the point distance, correct? If it present on the radius, then what is the small r? Capital R, because it was present on the surface. No, it takes the distance of the circle radius, okay, conducting sphere radius. So what I will get to confirm this? Okay, let us check it, like it was correct or not, the potential is getting correct or not, because you have to get potential on the surface. If you consider the surface of the conducting sphere, you have to get 0, correct? So checking the VP value. So at small r is equal to capital R, VP is equal to 0. So I have to confirm it. So I took VP is equal to Q by 4 pi epsilon naught. So I am taking smaller, in the place of smaller I am taking capital R. So root over r square plus a square minus 2ar cos theta minus 1 by root over here also. If I take capital R here, if I take capital R here, r get cancelled. So finally I will get a whole square. So a square plus here r square minus 2ar, 2 in place of smaller capital R into cos theta. Okay, so see the both terms are equal, 1 by root over r square plus a square minus 2r cos theta, root over a square plus r square minus 2r a cos theta. This one get cancelled. So q by 4 pi epsilon naught into 1 minus 1, which was q by 4 pi epsilon naught into 0, so which was 0. So see, if I take at r is equal to r, so if I take at r is equal to r, I got value of potential is 0. So this was correct. Yeah, so finally by taking a conducting shell which was grounded, I took potential at point P and induced charge. If it is not a grounded, like if it is grounded, the potential on the conducting shell was 0. But if it is not grounded, if you take at certain distance smaller, if you can find, no, because if you know the smaller you are taking at a certain distance, you know the a at which the initial charge was present. So 2 into a cos theta, angle with which the point P was present, you have to find at point P. So angle you know, same. Yeah, radius you know, smaller distance you know, a you know, like initially you know all the values, so you can find the potential at point P, correct? So yeah, this is the finally we got the potential at point P and induced charge. Yeah, thank you.